right, today we're cracking a code, a fundamental code that, believe it or not, secretly describes so much of the world around us. And no, it's not some top secret cipher, it's the quadratic equation. And trust me, by the end of this, you are going to see it absolutely everywhere. Okay, let's dive in. So think about it for a second. A basketball arcing towards the hoop, a massive suspension bridge, a satellite dish. I mean, at first glance, they have nothing in common, right? One's sports, one's engineering, one's communication. But what if I told you they're all connected by the exact same mathematical idea? Stick with me here, because the answer is actually pretty cool. The big secret? It's the parabola. That beautiful, perfect arc is the picture of a quadratic equation at work. It's the path of a ball flying through the air. It's the shape that gives a bridge incredible strength. And it's the curve that lets a dish focus signals from space. And really, that's just scratching the surface. Let's see how deep this rabbit hole goes. Seriously, they are everywhere. From plotting the path of a rocket in physics to figuring out the sweet spot for maximizing profit in a business, even just calculating the area of a room. Quadratic equations are this critical tool that lets us model, predict, and, optimize the world. And that is why getting a handle on them is so powerful. So we know why they matter. Now, let's get into the nitty-gritty of what a quadratic equation actually is. We're going to tear this thing apart and see what makes it tick. At its core, it's what's called a second-degree equation. And that name, quadratic, is a little clue. It comes from the Latin word quadratus, which just means square. And that's the whole key right there. The variable, which is usually x, is squared. It's raised to the power of 2. And this right here, this is the blueprint, the universal standard form. You can write any quadratic equation to look just like this. The a, b, and c you see, they're just numbers, are coefficients. A is the number hugging the x squared, b is the one with the x, and c is just a constant, hanging out by itself on the end. Now, there is one golden rule, one non-negotiable, can't break it rule. A cannot be 0. Think about it. If a was 0, that whole x squared term would just disappear. And poof, your powerful, curvy parabola collapses into a boring old straight line. That single term is what gives it all its magic. Okay, so we know what it is. Now, how do we solve it? When we talk about solving it, we mean finding the roots, those magic values of x that make the whole equation true. And to do that, we've got a fantastic toolkit with 3 main tools. First up is factorization. This is your speedy, elegant option for simpler equations. Then you've got completing the square, which is a really clever method that's also how we derive our third and most powerful tool, the superstar of this toolkit, the quadratic formula. This thing is the universal key. It will unlock any quadratic equation you throw at it. And here it is in all its glory. It might look a little intimidating at first, but it's your most reliable friend. You literally just plug in your a, b, and c values, do the math, and it spits out the answer. It's your get-out-of-jail-free card when factorization just isn't cutting it. Now, what if I told you there's a little secret, a sort of cheat code, hidden right inside that powerful formula? A tiny piece of it that acts like a crystal ball, telling you what kind of answers you're going to get before you even finish solving. You know that feeling, right? You're working through a problem and you think, wait, am I supposed to find 2 answers here, or just 1, or maybe there's no answer at all? Well, it turns out we can figure that out in one quick step. Meet the discriminant. It's that little chunk, b squared minus 4ac, that lives under the square root in the formula. And its name is perfect because its job is to discriminate, or, tell the difference between the types of solutions you're about to find. And the logic is actually super straightforward. If the discriminant is a positive number, you're taking the square root of a positive, which gives you 2 different real answers. If it's exactly 0, well, the square root of 0 is just 0, so you only get 1 repeated answer. And if it's negative, well, you can't take the square root of a negative number, at least not with real numbers, so you have no real solutions. It's an amazing little shortcut. Okay, theory is great, but let's get our hands dirty. We're going to take everything we've just talked about and apply it to a simple, real-world problem you could totally run into. All right, let's walk through it. First, the setup. We'll call the width x, and we're told the length is 3 more than that, so x plus 3. Next, let's make the equation. We know area is length times width, so x times x plus 3 equals 40. A little rearranging, and boom, we've got it in our standard form. This one looks pretty easy to factorize, and we get 2 possible roots, -8 and +5.
But hold on, here's the most important part: interpretation. Can a garden have a width of -8 meters? No way. That makes zero sense in the real world. So we just reject that answer. And that leaves us with our one logical answer. The width has to be 5 meters, which means the length, which is 3 more, must be 8 meters. Let's do a quick check. 5 times 8 is 40. Perfect. It all works out. So let's recap the pro tips. 1. Always get your equation into that standard form first. 2. Clearly pick out your A, B, and C. 3. Check the discriminant first. It can save you a ton of time. 4. In word problems, use common sense. You can't have negative distances or time. And 5. Always try factorization first. It's faster. If that doesn't work, bring out the big gun, the quadratic formula.
See, the quadratic equation was never just about a math class. It's a language that describes how our world actually works. That code is all around us, in physics, in nature, in finance. So the real question is, now that you can see this pattern, what other codes are you ready to crack?